Okay, for today it's DeMoives, and it is technically in section 17.3. It's complex numbers, day 4. And here are the 3 rules you have to know: the product rule, power rule, and the quotient rule. But none of this means anything if you can't do cis form, because notice they're all in cis form. So I want to back up a notch and say, here's a practice problem for you. Do you know how to take this and make it into cis form? Because if you don't, we got to start there. This is a complex number I'm going to call Z, or you could call Zeri or Zorg. It's just a name for a polynomial. Z isn't like a super variable that's always used for these. It's just commonly used for them. You don't have to say, oh, it's Z, therefore it's a complex number. No. Okay, I'm going to pause for a second and ask you to show your cis form of this to the kid sitting next to you. Okay, so there's a few kids that are stuck. Here's how you start. You go to the right one because of this, and then you go up or down for that. In this case, up, and we're going to go up however far our square root of 3 is. It's bigger than 1, I know that much, but then I put a dot here, and this distance was 1, and this distance was square root of 3. Are you with me so far? And then all of a sudden it's like, oh, I recognize that one. That's the 1, 2, square root of 3 one. So that's a 2. And therefore, I know the angle also. This angle that's across from the root 3, that's a 60. Usually we say it in radians, so that's going to make it pi over 3. So this is 2 cis pi over 3. Raise your hand if you knew that. Okay. If you didn't know that, you got to get that part down and look at what I did closely. Okay, and this is the x-axis and the y-axis. Just to clarify, that is putting it from what form into what form. They're both complex. It's complex what into complex what? Complex rectangular into complex polar. Okay, good. So once you got the cis form, the cool thing is, if you had another one of these, and that was Zorg, let's make this one here, just a second. Slide him over a little bit. And now let's make room for Morg. Okay, fine, it'll be Bob. And Bob is going to be -1 plus, let me think, I should get numbers that work nice. I'll just cheat and use square root of 3 again. I'll say -1 minus square root of 3i. All right, now, just for a second, if I had asked you to multiply Z times B, Zorg times Bob, you would have been able to just FOIL it, right? First outside, inside, last, but there'd be a whole lot of multiplying, a whole lot of outside and inside that have to go together, and then the last, you have to make sure also that you never have a square root in the denominator and all that stuff. But if we do it in cis form, you can multiply them together very easily. Okay, so if you get things in cis form, like the red one, Zorg, turned into this black one, 2 cis pi over 3, would you find the cis form of the B? And then I'll show you how you can multiply these so much easier when they're in polar form. I'll pause while you try to change B, or Bob, into polar form. So by now, you have changed this to cis form. I'm going to remind you how you would have done that. 1 to the left for this, and down root 3. And so this is down root 3. I don't know what it is. It's a little bit more than 1. And I put a dot here, and you should say -1 and negative root 3 because of where we went. Now, we've put ourselves in the third quadrant. This is an interesting place because some kids will do their angle wrong. Okay, so would you agree that this is the same 1, 2, root 3 triangle, and therefore the modulus, remember that's what it's actually called? The modulus is 2. The radius, the r, is 2. So if we're doing 2 times cis theta. What is theta? Well, first of all, the theta that's in here is a 60-degree angle, also known as pi over 3. But we don't go this way to get there. Why? Because the angles in here can be as big as pi or as small as negative pi. So I have to get to this a different way. It's negative 2 pi over 3. If you said positive 4 pi over 3, it would be wrong. It would be marked wrong on a test. This is all polar. I should say all complex polar. Yep, this is new rules for complex. Do you remember when we got to inverse, and inverses had new rules for inverses? Because you can't take inverse of all of sine, but you could take inverse of only part of sine. Only that one part of the sine graph would actually have an inverse. Well, same idea. There's new rules for this. If you didn't catch that already, this zone, when you're doing polar, that's the negative zone, from 0 to negative pi. On the top, the angles up in here would be from 0 to positive pi. Okay? All right, so now that you know that, how many of you would agree that it's 2 cis negative 2 pi over 3? Okay, good. Why did we do that? Because now we've got them in cis form, and you can do stuff to them. Like, for instance, I'm going to go back to this slide that's got all the fancy verbiage on it. Let's try to learn it from this, because part of my job is teaching you math, but part of my job is teaching you how to learn math. And sadly, I do think it is sad, but it's true. You sometimes don't get it from your teacher. You don't understand it, and you have to go to the book. You are going to be moving on to math teachers that sometimes will say, I want to do this really cool problem in class, but I don't have time to teach you this thing, so you'll just have to learn it from the book. When you go to college, this happens a lot of times. Teacher will do like all hour on one really hard problem, and they can't cover everything, and so they expect you to learn it from the book. If you look up here, these are very clear descriptions of what you would do with z and w being your two complex numbers in polar form. And this is how you would multiply them. This is how you would put them to a power. That's what Mr. DeMoives is famous for. And this is how you would divide them. Would you just look that over for a moment? And I'm going to ask you in a moment to multiply the two numbers we just put into cis form. That's product rule. That's right here. You got to tell by the context. N is not defined as something important at the beginning. It just shows all of a sudden z has been put to the n power, and so that n shows up again here and here. It tells you what to do with a power you put on your complex number. All right, so one thing at a time, let's look at the product rule. Do you get that when you multiply z and w, you are going to take their two radiuses? In this context, they're called what's, remember? The modulus. They're two modulus, also known as the r's, and you're going to do what to them? If they're just sitting right next to each other, doesn't it imply multiply? Yes. So you're multiplying the moduluses. Well, it makes sense. You're multiplying them, so you'd multiply their moduluses. And then you would add their angles. That's it. That's all there is to it. So let's go back to the one we were just doing. And I have these two. If I wanted to take Zorg plus Bob, that I can't do. Sorry. Zorg times Bob. There we go. If I'm multiplying them, I will get, technically I should use a lowercase b, sorry. I will get the modulus is multiplied. 2 times 2 makes 4. Cis, what do you do with the angles? Add them. Pi over 3. Notice the first one you use, the z, is the first one in here. In adding, does it really matter? No. In subtracting, does it matter? Yes. When you're subtracting two things, you go 5 minus 4 and 4 minus 5. They're different. Okay, so pi over 3 plus negative 2 pi over 3. Since they have the same denominator, this one's pretty easy. It's the final answer. 4 cis, what? Negative pi over 3. We just multiplied them. Now just think for a second. If I had said to multiply these and you chose to do it in their rectangular forms, could you multiply these two numbers? Sure you could. You'd have to FOIL them. First, outside, inside, last. It would be long and complicated, lots of algebra, and you'd have lots of chances to make little mistakes. This is way easier to do it in polar form. All right, we're going to just do a quick run through of a couple more. Like, let's say we wanted to take these two that we painstakingly changed into polar and take z divided by b. Don't do it in the rectangular form because it'd be a pain, because you'd have square roots on the bottom and you'd have to multiply by the complex conjugate to get rid of that, and oh my gosh, way harder. So much easier if you're in cis form. So take a wild guess what you do with the r's, the moduluses. You divide them. 2 divided by 2 is what? 1. So it's 1 cis, and then what's the angle? Dividing goes with subtract. So I'm going to subtract, and now it does matter. The first one we used is the first one we put in here. Pi over 3 minus 2 pi over 3. And what does that make? Yes, we'll have to fix something, but first let's get what the answer is. 1 cis is the same as cis. I suppose I could put 1 cis. It looks a little weird to have it naked up in front. So that's full frontal nudity math-wise. Anyway, so I'm going to put the 1 in there. And now we have pi over 3 minus 2 pi over 3, which makes what? Negative, how many pi over 3? Oh, just negative pi over 3. Okay, is that in the allowed range? Yep. Oh, you're right. It's minus a negative. Thank you. I get it now. I thought you were just saying that we were going to get an answer that was not in the, like you'd have to convert it from its normal location to a negative. You're right. It was minus a, what, you don't think that's right? Minus a negative. Do you agreeing with this? Okay, good. So then that means plus, and that's is going to bring up an issue. What is pi over 3 plus 2 pi over 3? Pi over 3, or just, sorry, it's just pi. Now, is pi allowed? Yes. You can go from 0 to pi. Or you could go from 0 to negative pi. Aren't they the same place? So which do you think we say wins if you're picking between pi and negative pi, considering they bring you to the same place? Pi. Because it's simpler. Pi. All right. So our answer on that one, when we divide 2, was we divided their moduluses and we subtracted, which in this case subtracting a negative made us add, their angles. Now I want to show you someplace where that happens also. Log x, y. What does that turn into? Log x. Notice, multiply turning into add. Same thing, isn't it? It's like an echo of the past. How about this? Log x divided by y. What does that turn into? Log x minus log y. Again, echoes of the past. The history doesn't repeat itself, but sometimes it rhymes. Okay. Famous quote. Back to this one. I'm going to use this one for your example of DeMoives. Which one of these 3 is actually DeMoives? 1, 2, or 3? Problem 2 is a DeMoives problem. Okay, so first thing we got to do is turn it into polar. Because, believe me, you don't want to actually do this -1 plus I root 3 to the 5th. You could, but oh my gosh, you'd have to actually write it out 5 times and keep foiling and foiling, and then it wouldn't be foiling anymore because you'd have a triple times a double, and then oh my gosh, you could do it. It would take you literally probably an hour. Okay, and you'd probably make a mistake in it somewhere. So we should instead, everybody, please make me a little picture for this and figure out what its cis form is. Once we have its cis form, we can do DeMoives on it. I'll pause for a second while you find cis form. Okay. So we're going to -1 and positive root 3 because this says -1, which means go that way. This says positive root 3i, or I root 3 is in that direction. So then I put a dot right there, and that's where we are. But drawing the triangle is what helps the most. And this is -1, and this is root 3. And notice it's -1. And then it's still that 1, 2, root 3. Just keeps coming up like a bad penny. Have you heard that saying before? Did you hear they're changing the $20 bill? Harriet Tubman. All right, it's going to be cool. Harriet Tubman was born a slave. She was a tiny black woman. She was brave. I'm quoting a rap song now. Okay, I think I've reached my lowest point. All right, so this is theta, and theta is, let me think, theta is a 60, and so this is pi over 3, and so this is 2 pi over 3. Whew, did you get 2 cis 2 pi over 3? Raise your hand if you did. Okay, good. Anyway, so if you take 2 cis 2 pi over 3, I can DeMoives that. All right, so watch and learn. You get to see how DeMoives is all about DeMoives. Would you agree that I am putting this to the 5th power? You with me so far? All right. I'm putting this to the 5th. So DeMoives is all about DeMoives of the exponent. There we go. 2 to the 5th, which is 32. Cis of that, which is 5 times 2 is 10 pi over 3. And I'd cry a little bit and mark it wrong because 32 cis 10 pi over 3 has an angle. The argument, by the way, in case you ever were noticing those ARG things earlier, again, not something I expect you to know the terminology for, but the argument, which is that arg, yes, it should be on Pirates Day. The arg is too big. I'd like you to figure out where 10 pi over 3 is. Just go like, okay, here's 1 pi over 3, 2 pi over 3, 3 pi over 3. Figure out what 10 pi over 3 is and give it a new name that's between 0 and pi or 0 and -pi. Okay, here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6 pi over 3, 7, 8, 9, 10. It's that one. So I'll erase those and redraw it a little prettier. There. So it's still pi over 3s, but we should go this way and say it's negative what? 2 pi over 3. 32 cis negative 2 pi over 3. Tough stuff, but how many of you got it? Good. You've DeMoives'd. All right. Yes. Yes. That was the genius of it. That's what kept people from figuring this out for a while until Mr. DeMoives did. Is you would think you'd put the power on here, wouldn't you? Or at least that you'd put the cis to a power, like the whole thing to a power, but it was all about the angle. So he's the one who figured that out, and so he's the one who named it after. It works. I could do a long proof for the next hour, and your eyes would cross after 2 minutes, and you'd stop listening. But it's true that that power can just be multiplied by the angle. All right, so this is the part where we should actually jump into some homework and start your homework together, because you've learned how to multiply them. Well, multiply involves doing what to the angles? Multiply goes with add, remember? When you divide them, gentlemen, focus. When you divide them, what do you do to the angles? Subtract them. And lastly, when you DeMoives, it's all about DeMoives of the power. All right? So, here is our homework. It takes about, I don't know, you're going to probably get carpal tunnel syndrome trying to slide down to this one, but 27th page. Thank you. There it is. These first four are all DeMoives, but they're DeMoives with a twist. Sounds like a drink. So this is just DeMoives, but this is a DeMoives with another DeMoives, and then you got to multiply them. But tell me, what should come first, power or multiplication? Powers, and they still follow those rules, thankfully. So you do the DeMoives on the z, which is all about taking the exponent and moving it down. It's a DeMoives of the exponent. Okay, and then when you're done, you got to multiply them, which means you add. So this one's kind of complicated. Let's do it together. First, before we do any of that, we have to find the what form? The cis form. All right, so let's try to find cis form of z. Okay, so, ooh, those are ugly numbers. Negative that, whatever it is, I'm going over this far, and positive that means I go up that. So I'm going to put my dot here, draw my triangle, and then I can go, okay, maybe I should make that a different color here. And then I can say that this is negative 3 root 3 over 2 and positive 3 over 2. I'm noticing that there's a 3 over 2 theme here. Do you get that this is kind of like 1 times root 3 over 2? And this one's kind of like root 3 times 3 over 2? So what's the last one gotta be? If it's a 1 and a root 3, what should be here? A 2 times by what? Root 3, or just, sorry, 3 over 2 times by 3 over 2. All right. No, not root 3. Times by 3 over 2. So that makes this 6 over 2, also known as 3 right there. Now, could you have done that by squaring both of them and then adding them? Absolutely. I'm just trying to show you a shortcut. Otherwise, you'd have had to go square root of this one squared plus that one squared, and it would have still worked, and it would have given you 6 over 2, which is 3. So it would have given you 9, actually, and you take the square root of 9, and you would have gotten 3. So yay, I figured out the R. The modulus is 3. So now I can do my cis form. It's 3 cis, and then I got to figure out the angle. Okay, if I am in the 1, 2 square root of 3 triangle, it's a pi over 6, so it's 5 pi over 6. Very good. There we go. 3 cis 5 pi over 6. Now that you're going to use like a million times on problems 45, 46, 47, and 48. So you may want to, write that down nice and clear. My 5 pi is not looking great, so I'm going to clean that up. It's 5 pi over 6. Now this is the 30, 60, 90 triangle. So if it's across from the 1, across from the 1 is a 30, so that's a 30, so it's a pi over 6. So yeah, it's 5 pi over 6. Okay, so now I'm going to do what to it? I'm going to cube it. So I'm going to take 3 cis 5 pi over 6. Is there anything wrong with that yet? Oh, okay, you're right. I was doing 46 for you. I'm sorry. That's 46. So z is 3 cis 5 pi over 6. Some of you are still talking. Please stop. And then that has to be put to the 5th And I suggested that that was all about DeMoives of the exponent. So that goes down here and becomes 3 to the 5th. Icky. So icky, in fact, that you can just leave it as 3 to the 5th in the answer. We don't need you to use a calculator. Calculators aren't allowed in the test anyway. And then this becomes 25 pi over 6. Whew, that's a lot of pi over 6s. It's too many pi over 6s, in fact. 24 pi over 6 would have been 4 pi, right? And so you're right. It ends up just being pi over 6. So this is... And I saw he went by on the wheelchair and he was smiling very big. So it was okay. No deaths were involved. CIS of 25 pi over 6. There we go. Okay. Oh, wait. When we figured out that that was the same as 24 pi over 6 plus 1 more, which is 2 pi, 4 pi, plus 1 more pi over 6. So it's just pi over 6. Whew. Wow. There we go. There. I did z to the 5th. Now you got to do w squared. All right. So let's find the cis form of w. I want to save some time. Somebody's probably already cranked that out by now. What'd you get, sir?
I got 6
Can anybody verify it? Has anybody else tried that one? Negative pi over 4? And you got the same thing? Awesome. Then that's our w. So now I'm going to do the w squared part. So here's my w squared part. You know what? I'm going to let you guys skip number 47 because it's pretty much identical to 46. And it'll give you room to work over there. So here's w squared, which is 6 cis negative pi over 4. And then I have to square it. So I'm going to just know how to do this. I'm going to square this one. And I have time. I'm going to put them in blue. There and there. Okay, so that's going to be 36 cis, and thankfully that's a small number. It'll stay under negative pi. So it's negative pi over 2. Cool. But now I have to multiply this times that, see? So it's this times that. But that's not that bad, except that you're going to have some gigantor number in front. You can leave as 3 to the 5th times 36. Or 36 times 3 to the 5th. Cis, and then do you add or multiply, or sorry, add or subtract the powers? When you're multiplying, you add them. So now I got pi over 6 plus negative pi over 2. If they were common denominators, it'd be easier. So yes, you have to find a common denominator. So pi over 2 should be changed into 6's, and it would be 3 pi over 6. Would you agree? All right, so then pi over 6 plus negative 3 pi over 6 makes negative 2 pi over 6, also known as negative pi over 3. So it's this 3 to the 5th times 36 times, or cis, it is times cis, but we just say cis, negative pi over 3. Did I get that right? Cool. That's a pretty intense math problem. That involves both the power rule, which is DeMoives, and the power rule and the exponent rule. No, I'm not saying that right. I should go back and look. But anyway, one of them's DeMoives and one of them's just multiplying. Okay, there we go. So that's a good example of one, and it's right in your homework there. So we have 45. 46, we're skipping 47, and you're going to do 48. That involves doing a simple little DeMoives. Now that we got cis form, it's way easier. Okay, then on the next page, I deemed that this homework was a little too long, so you may skip number 64. Do you think I really want you to write this out 5 times and FOIL it over and over and over again? Of course not. What should you do first then? Find the cis form. All right, good. And then you just use DeMoives. Notice me throwing that saying around like I know what I'm talking about. So you could too. Makes you sound mathematical and smart. In calculus, you'll get a whole bunch of things like that. You know, you're going to DeMoives this, and you're going to Gaussian that, and anyway. So I'm just throwing around words that make me sound smart. You'll have a lot of them in calculus. All right. You may also skip 55. Notice this one says find r and theta first. That's kind of a hint to put it in cis form. Okay, and that's it. And that's all you have. Get them done. And tomorrow we're also going to get your labs, so make sure you have 2 labs ready to be graded for tomorrow. And that's all I have for you for today.